Good morning all. Today we'll be discussing about TCP/IP protocol suite. So already we have already discussed about OSI model, and even you know what is a protocol suite as well. So what is a protocol suite? It is nothing but you have a set of network protocols cooperate together. It's called a protocol suite. So TCP/IP suite will be including numerous protocols across layers. So you have a data link layer, you have a network layer, transport and application layer. These layers will be working together in order to enable the internet connectivity. Now we'll have a short discussion on TCP/IP. So what do you mean by TCP/IP? So TCP already we have already discussed about OSI model. In that we have a layer called as transport layer. In that we discussed about transmission control protocol, and you also know about a network layer where we would have discussed about the internet protocol, IP protocol. So the combined TCP and IP is going to act, and it is going to act as a suite of communication protocols, so that you can able to exchange data between two devices possibly. And this model is going to specify how data should be packetized, addressed, transmitted, routed, and even received on a network by providing end-to-end communication. So as we have seen the OSI model, which is a theoretical model, and TCP/IP is an application model and a practical model. So we'll be seeing an overview of the model and its functionalities, its advantages and drawbacks as well. Now this TCP/IP, as stated, is one of the many internet protocols created by DARPA, so the Defense Advanced Research Project Agency in the United States during the year 1970s. Then the TCP/IP model was later adopted as a standard protocol for ARPANET, the modern internet predecessor. Okay, so TCP/IP is now the international standard for internet communication. So as you can see in the slide that it is the most widely used interoperable network protocol architecture. So even then it has been developed before OSI model. It was OSI was slow to take, so specified and extensively used before OSI, and OSI was slow to take place in the market. And because of the advantages that we can able to infer from the TCP/IP protocol suite, it is evolved in the market when compared to the OSI model. Actually, the OSI model is a theoretical model, as said, and you could see like the original TCP/IP protocol suite is actually defined as a 4 software layers built upon the hardware. However, TCP/IP is thought of as a 5-layer model as well, similar to the one we have already studied in the OSI model. Okay, and this model is used widely by the internet and the World Wide Web, and we also discuss about what are the applications that is using this TCP/IP protocol suite when we move ahead. Okay, now again we'll also see in detail about the TCP/IP model. So the TCP/IP model is actually created to allow communication over long distances, possibly between two devices. So whenever you are having a video conferencing, or you are sending us text messages and all, how this TCP/IP model is going to work and how it allows us to communicate over long distance, that is possible only because of this TCP/IP model. And it also allows us to assist in how the data, so it allows communication, and communication in the sense how you are going to transfer the data between two devices over the internet. And that means whenever the data gets transferred, we also know how the data should be packetized, or how it should be addressed, and how it gets transmitted, routed and received on a network by providing end-to-end communication. So the TCP/IP model consists of 5 layers: the application layer, the transport layer, the network layer, the data link layer, and a physical layer. So each layer is responsible for a particular task strictly according to the protocol. So each and every layer, as we discussed in the OSI model, each having its own job. Okay, so TCP specifies how application will establish communication channels across a network, and also controls how a message is split into data packets sent over the internet and reassembled in order at the destination address. So you're sending a data. So that data is fragmented or splitted into some multiple packets, and we will be sending it over the internet, and at the other end we'll be reassembling it. Okay, and so that we can able to get the entire message. So TCP specify how it is going to establish a communication channel, and IP, as mentioned, it is a network layer protocol. It is going to specify how each packet should be addressed and routed to ensure that it delivers at its destination. So in order to identify where the message should be forwarded, each gateway will be having its own IP addresses that we already studied in OSA model. So now we'll see how the TCP/IP protocol works. So whenever we send things like a simple text message, a file, or a video message over the internet, the TCP/IP model divides the data into packets. So according to the 5-layer or 4-layer architecture. So each and every textbook or the web, it is specifying like a 4-layer or 5-layer, depends. It is not a problem with some people would have combined this data link layer and physical layer into a single layer, and some people will be mentioning it as a 4-layer. So the data will be going in order from the sender side, and on the receiver's order it follows the reverse order, and it is finally reassembled at the receiving end. So TCP/IP is again based on the client-server communication model. Yes, so that actually the TCP/IP reference model has been built upon its protocols. The whatever we have studied in the OS model, similar to that, it is also built upon protocols, and this is why it is not so important to assign roles to each layer in TCP/IP. So because TCP has its own responsibility, and IP has its own responsibility as well. Now this is the layered architecture of TCP/IP, just a comparison of OSI versus TCP/IP. Okay, in OSI model you could see like application transport network. So application presentation session transport network data link and physical layer. Actually I should start from this layer. So physical data link network transport session presentation and application layer. When you compare this TCP/IP protocol suite, it is not going to have a session and presentation layer. Apart from that, the remaining things are same. So the application layer is going to act as the combination of the session, presentation, and application layer. The remaining things and all similar. Okay. Now we'll be discussing about like how this protocol is going to work. So as I said, like whenever you send things like a message or file or a video over the internet, the TCP/IP model divides the data into packets, and then the data goes in from the sender side, and on the receiver side it follows the reverse order, and finally we will be reassembling it. So TCP/IP is based on the client-server communication model, which means that user or the client sends a service request to a second or to the web host or to the server, such as forwarding a web page. TCP/IP also uses point-to-point communication, which means that data is sent from one host computer to another within a defined network border. So you will be having a limited coverage. Okay. So in TCP/IP model, each client request is unique and unrelated to the previous one, so that you can able to identify which message you have sent. Okay, because of its unique property. So hence it is called as stateless, and because of its statelessness, it allows network channels to be used indefinitely. And this entire process is standardized. The TCP/IP model works very well. So if we don't have a standardization, communication would go haywire, and the fast internet service relies on the efficiency. So as we have discussed about these 5 layers, so now um, you have the data link, the network access layer, and the physical layer. You have a separation, and it is done in order to achieve the client's requirement, in order to get a client's requirement with a greater efficiency. So now what are the different layers? So we have application layer, and we have transport layer, network layer, data link layer, and a physical layer. So first we'll discuss about the application layer. So the application layer performs the functions of on the beneath, like the your transport layer, network layer, data link, and physical layer. So in order to it's like why we need the application layer, as the name implies, application. In order to have a user interface specification, we have all these kind of we have all these type of layers. We have this particular set of layer. So what are the different protocols we have in application layers? So it includes HTTP, post office protocol, SMTP, and file transfer protocol. So your payload is the actual application or application data what we have sent. So HTTP, as the name implies, it stands for HTTP stands for hypertext transfer protocols. It enables us to access data via the internet. So for example, if you are sending data in plain text, audio, and you can able to send data in plain text, audio, and video. It is called a hypertext protocol because it is efficient enough, it is efficient enough to use in a hypertext environment. That's why it is called as hypertext transfer protocol, and you will be having a rapid jump from one document to another document. Okay, and telnet, in telnet we can able to establish a connection between the local and the remote computers in such a way that the local computer seems to be a remote terminal. So here actually the application layer is not discussed in detail. That's why I have not moved the slides, and I'm just discussing about the application layer. So SMTP, it is used for simple mail transfer protocol. So it is the this particular layer handles email. The data is sent to another email address using this protocol only. And FTP stands for file transfer protocol, for transferring a file from one computer to another. Okay, that's all about the application. So the application layer is actually used for controlling the user interface specifications, or it is responsible for node communication. What are the different protocols that are used in application layer are HTTP, SMTP, Telnet, and FTP. Now we'll discuss about the host to host, or the transport layer. So transport layer, it is used for end-to-end data transfer, and so you would have studied in OSM model about port addressing and all, and it mainly whenever we talk about this transport layer, two protocols comes into our mind. One is your transmission control protocol, and your and your user datagram protocol, UDP, TCP and UDP. As you know, TCP is a connection oriented and UDP is a connectionless, and you have a reliable delivery of data in terms of TCP, whereas in UDP the delivery is not guaranteed, and you have an ordering of delivery. Because of its reliable delivery, you can able to have an ordering of delivery in case of TCP protocol. Now now we'll discuss in detail about this transport layer, or you can call it as host to host layer as well. So again, this is similar to what we have studied in the OSA models transport layer. How much, so it is going to, we will be using this layer in order to specify how much data should be sent when it should be sent, where, at what rate you can able to send the data. So the message from the application layer is built upon this layer. So in order to ensure that data units are supplied in a timely and error-free manner, we have this transport layer. So through error control, flow control, and then segmentation, desegmentation. So the transport layer helps to control the links reliability. So this transport layer also because of TCP and all, you would have heard that like it is going to acknowledge the successful data transmission and sends the next data if there is no error. Okay, and there are the two most popular protocols that we have in transport layer, TCP and UDP. So TCP, you know that protocol is very well for a reliable communication or a connection oriented protocol, and it does data segmentation and sequencing. And because of this acknowledgement feature, we can say that this TCP is a reliable protocol as well. It also uses flow control method to govern the data flow between the systems, and because of all these features, it also has some kind of overhead because of this reliable transmission. That is one kind of drawback. And you should also very much it is also very much important to know that it is a three-way handshaking protocol. So in order to establish a connection and acknowledge the connection between the two devices, we have this three-way handshaking that we will be studying in detail about transport layer in the forthcoming units. In detail we will study this TCP. That time you can able to understand what's a three-way handshaking under. And UDP, and you call that it's a connectionless protocol. If your application if for example you are designing an application and that application does not require any dependable transmission, then in that case we can go with this kind of protocol because of its cost effectiveness. Whereas if you want to have a reliable communication and your acknowledgement is very very important, in that case we can go with a TCP protocol. So, and the problem here is whenever you are going to design a cost effective application, definitely the main choice you can go with an UDP. And the problem here is it is not going to give you any assurance of data delivery. And in the slides it has been given that one, can you give some example application that use TCP and UDP? So what I can say is like a text communication. So you all know what is the importance of text communication in the present time. So any discrepancy in texting between the sender and receiver, we cannot able to tolerate. So hence TCP is used in text communication to its reliable transmission, error control, and in order receiving of the data. So whatever, like we are sending some data in WhatsApp, we are sending some Instagram messages or Google Chat, all these are text messages, and these text messages definitely need to use TCP. That's why even when the like you can able to see a blue a gray color tick, a double tick, a blue color tick. So all the underlying protocol is used as your TCP. And in case of UDP, like in that case your reliable transmission is not that much required, and we want to design a system which is very cost effective. In that case we can go with an online games application. For example, like most of the online games we use, use the services of UDP, since the amount of delay you can able to tolerate in online games. So UDP is widely used over TCP, which is actually quite slower. And you can also in UDP UDP does not retransmit the lost data, and it is a connectionless protocol, due to which it is much faster. So your all online games uses UDP. So this is the real time example we can able to give for a TCP. There are many other applications as well. Let us talk in detail maybe in the fourth whenever we discuss about transport layer. So next comes the application layer we have discussed. Now this is we'll be discussing about the internet layer. So we discussed about the application layer, we discussed about the transport layer. Next comes the internet layer. So internet layer or otherwise called as the network layer. The main function of network layer, as the name implies, it is going to send packets from the source to the destination, regardless whatever route it follows, and it is going to provide a functional, or you can say that a procedural mean for sending a variable length data sequences between nodes across multiple networks. And what are the different protocols that lie in this network? Or we have this IP and we have ARP. And also IP, internet protocol, is in charge for sending packets from a source host to destination host based on the IP addresses. And we have two variations, as we know, like IPv4 and IPv6. And IPv6 is the it has more advantages when compared to IPv4 because of the higher rate of increasing number of, or the increasing rate of devices that are connected to the IP. So that we'll discuss. Okay. And address resolution protocol, or ARP, is a protocol for resolving the conflicts between computers. So the main task is to determine a host at hardware address from an IP address. So whenever we have a MAC address, how to how it is going to find out the IP address, or whenever we have an IP address, how it is going to convert it to an a MAC address, that the logical address to a physical address, or logical address in the sense the IP address, and the physical address is in the sense the MAC address. So ARP's function is to convert the 32-bit addresses to 42-bit addresses, and the vice versa. So we have a reverse address resolution protocol as well. So ARP is necessary because IP addresses in IP version are 32-bit long, but MAC addresses are 48 bits long. And so next comes the again, it is also a connectionless point-to-point internet working protocol, because all these points we have already discussed in OSI model. So I'm not discussing in detail on this. I have talked more on IP and the ARP. So next comes the link layer protocol. Next comes the network access and physical layer. And in the TCP IP reference model, these things are not discussed in detail because this protocol is not defined by TCP IP. Mostly it is in hardware, and a well-known example what we already have seen is Ethernet. Now this the link layer, it specifies the physical transmission of data over the network, or it also handles data transmission between two adjacent devices on the same network, and how each and every bit should be optically signaled by the hardware devices that interface directly with the network media, such as you have a coaxial cable or optical cable, fiber cable, or twisted pair cable. So finally we can conclude that an application layer, so we have discussed about four to five layers. So application layer is responsible for node to node communication and control user interface specification. And what are the protocols we have discussed are HTTP, SMTP, Telnet, or some of its protocols. So now host to host layer, it is going to we'll be using this layer in order to know how much data we need to send, when we need to send, where, at what rate the data has to send. All these are host to host layer, decided by the host to host layer or the transport layer. The main two protocols we have discussed are TCP and UDP. And the third layer is your internet layer. The primary function is to send packets from the source to the destination, regardless of whatever route it follows, because all the routing is it can be carried out by the internet layer. And we discussed about IP and ARP protocols in this, belonging to this layer. And finally we have the network access layer and the physical layer. These two layers are going to handle the data transmission between two adjacent devices on the same network. And the main use of TCP IP model, as we discussed, this TCP enables a reliable communication, and whenever we send a text communication we can able to use this kind of protocol. And TCP IP is providing a suite of communication protocols in order to allow data exchange between the two devices. And UDP, we use this for online gaming or video streaming. Yeah, a delay we can able to tolerate the delay in case of online gaming and all. So that's all about TCP IP protocol suite. Thank you.